Assalamu alaikum. This is lecture 2 of software requirement engineering, and in this lecture we are going to discuss about several types of requirements, and subsequently we will differentiate between functional and non-functional requirements. And this lecture will also constrain some discussion about requirements specification document. So as you must be well aware now that the non-functional requirements are the requirements of system that put constraints on the functional requirements of that system. So non-functional requirements constitute of different set of requirements such as product requirements, organizational requirements, and some external requirements. And if you look at the product requirements, it is the constraint that enforce the achievement of functional requirement in a specified criteria. For example, you want to achieve some usability requirements that your system should be usable enough for in a specified time to meet the specified requirements. Similarly, there are some efficiency requirements, performance requirements, space requirements, dependability requirements, security requirements. These are the requirements that increase or enhances the functionality of your system or product. Similarly, there are some organizational requirements which also constitute some non-functional requirements such as environmental constraints and operational requirements or development requirement. For example, in which tool you want to create your product, or what are the operational operating systems or infrastructures in which you want to run your product. Additionally, there are some external requirements such as regulatory requirements from any government or non-government organizations, or some ethical requirements which must be specified by a typical society. Additionally, there are some legal requirements such as accounting and safety security requirements. And we will discuss each of these briefly in upcoming slides. So as I described earlier, that product requirements specify that the delivered product must behave in a particular way, such as achieving functional requirements with the speed, reliability, dependability, and efficiency, etc. Similarly, organization requirements, which are consequence of organizational policies, procedures, process standards, etc. And external requirements arise which from factors which are external to the system and its development process, such as interoperability requirements or some legal requirements. So here is an example of a product requirement that system should allow 100,000 hits per minute on the website. So it is basically a constraint on the functional requirement that your system must allow 100,000 hits per minute on your website. Similarly, the system should not have down for more than 1 second for continuous execution of 1000 hours. So this is the requirement which relates to the availability of your system. Similarly, if you look at the organizational requirements, the examples include that the system development process and deliverable documents shall conform to a specified standard. So any development work subcontracted by the development organization shall be carried out in accordance with the capability maturity model, or in short CMMI model. Similarly, if you look at the examples of external requirement, it states that the system shall not disclose any personal information about the member of the library system to other members except system administrator. So it are which are mostly the legal or administrative requirements. The system shall comply with the local and national laws regarding the use of software tools. So here is the example of the health management system, which the example we discussed in the first lecture, and you can go through this example to find out the product requirements, organizational requirements, and external requirements. So non-functional requirements are also classified as quality attributes, and there are several dozen product characteristics that can be called quality attributes. And software quality attributes classification is a one way to classify attributes, and it distinguishes those characteristics that are discernible or noticeable at runtime from those that are not discernible or noticeable at runtime. So another approach is to separate the visible characteristics that are primarily important to the users from under the hood qualities that are primarily significant to the technical staff. So you have to distinguish between the requirements of the users and the requirements of the developers or the technical staff using that creating that product. So if you are more concerned about the technical staff, it indirectly contributes to the customer satisfaction by making the product easier to change, correct, verify, and migrate to new platforms. However, there is some discrimination between the important quality attributes to the users and important quality attributes to the developer. Users want the best product and which serves best of their purpose, and developers want the same thing, but additionally they want that their product should be easy to manage and easy to change. So here is the table that represents two different important primary quality attributes with respect to users and with respect to developers. As you can see, availability, efficiency, and flexibility or integrity, along with reliability and usability of the product, are very important to user. That means user wants their application that is available all the time, it runs fast, it is flexible, and it is integrated with their other applications. It can run on different operating systems. It is reliable, robust, and it is easy to use. These are also the desired quality attributes of the developers as well. However, the main focus of the developers is to have an application that is easy to maintain. That means their code is easy to read and easy to replace and easy to modify. And additionally, they want their code to be or application to be portable to different operating system and different infrastructure. They want their application to have reusability so that they divide their application into the components which can be used either as a whole or a part into another application. They also want their application to have a good testability, that means they can easily test their applications. So now let's look at the brief details about each of the quality attributes important to the users and each of the quality attributes important to the developers. So first start with the quality attributes important to the users, and the first quality attribute is availability. Availability refers to a measure of the planned uptime during which the system is actually available for the users for the use and fully operational. That means the time in which your user is able to access your system and do its required functions. More formally, availability is equal to mean time to failure, that how often your system fails, for the system divided by sum of mean time to failure and the mean time to repair of the system after the failure is encountered. That also measures the availability of your system, that how often your system is available and how often it is offline or not available to your user. So the scheduled maintenance periods are also affect availability. So as you can see, many of your current product you are using also, such as banking application, also send you a message here that their system will not be available for some specific time. So which refers to the availability of your system. So some authors view that availability as encompassing reliability, maintainability, and integrity. So availability is a broader quality attribute which includes the reliability of system, that as long as the system is reliable, it will be available to your users. And also it is, if it is integrated with other systems and components, it is more likely to be available. So certain tasks are more critical than others and users become frustrated when they need to get essential work done and systems are not available. And you have to ask users what percentage of uptime is really needed and whether there is any times for which availability is imperative to meet the business or safety objectives. So every user would like to have a product that is available every time whenever the user needs it. However, availability requirements have become more complex and more important with the advent of websites and internet applications such as banking applications or social media or social network applications and other uh, applications related to work which are available to the users over the internet or worldwide or through local area internet access. That applications must have to be available most often than the offline applications. So for example, and additionally, to measure the availability, you have to specify metrics that can specify that how much the quality attributes being achieved. So, for example, in the availability case, the system shall be at least 99.5% available on weekdays between 6 a.m. and midnight local time and at least 99.9% available on weekdays between 4 p.m. and 6 p.m. So this provides you a measure to achieve your quality attribute, and if your system is meeting these measures, you can say your system has the availability quality attribute met. The next requirement in the consideration is the efficiency, which encompasses many more features such as speed and output time or throughput time. And efficiency tells us how well the system utilizes processor capacity, disk space, memory, or communication bandwidth. Efficiency is also related to the performance, which is another class of non-functional requirement. So if a system consumes too much of the available resources, the user will encounter degraded performance and a visible indication of inefficiency. So we would like to have a system which uses very less amount of time to perform our task and very least amount of resources, and in terms of time, space, and computation, or even the bandwidth. So you can consider a minimum hardware configuration when defining efficiency, capacity, and the performance goals. So typical users think that they primarily in terms of response times or disk space consumption, and you will also consider that the efficiency is also measured in terms of response time, that how often your system is responding and how fast it is to achieve your task and how much amount of space is required. So to gather these requirements, the analyst must ask the question that will surface user expectations regarding the issues such as acceptable performance degradation, demand spikes, and anticipated growth. Similarly, to measure the efficiency, you have to specify a metric, and to allow margins of unanticipated conditions and future growth, you might specify something like following. So another requirement of efficiency says that at least 25% of the processor capacity and RAM available to the applications shall be unused at the planned peak load conditions. Or another example should say that your system or your user should be able to achieve a task in less than 5 seconds. Or you can say your system should respond to the user within 1 microsecond. The next quality attribute to the user is flexibility, and it is also known as extensibility, augmentability, or extendability, and expandability. Flexibility measures how easy it is to add new capabilities to the product. So if developers anticipate making many enhancements, they can choose designs that minimizes or maximizes the software flexibility. So the attribute is essential for the products that are developed in an incremental or iterative fashion through a series of successive releases by evolutionary prototyping. So here is an example of flexibility that a maintenance programmer who has at least 6 months of experience supporting this product shall be able to make a new hard copy of output device available to the product, including code modifications and testing with no more than 1 hour of labor. So as you can see, this is a mixed requirement uh, which can be important to the users as well as the developers. So in case of extensibility and extendability, it is more important to users. However, if you look at the expandability of your product, or flexibility refers to the quality attributes which is more concerned with the developers. So a developer would like to have a new product, such as in this example, a new hard copy of your output device within specified time. And as in this case, it says with no more than 1 hour of labor. So next attribute is the integrity, and which encompasses security as well, and it deals with the blocking unauthorized access and preventing information loss, ensuring the software is protected from virus infection, and protecting the privacy and safety of data entered into the system. So integrity is a major issue with the internet. Software users of e-commerce systems want their credit card information to be very secure. So any system which includes the user's personal data or private data must have integrity encompassed in their quality attributes. Similarly, the web servers do not want personal information or record of the site that they visit to be used inappropriately, which is a major concern in these days. Web service providers want to protect against denial of service attack or hacking attacks, which also refers to the integrity of your product. Integrity requirements have no tolerance for error. State integrity requirements is unambiguous in terms such as it ensures the user's identity verification, that any user logging to your system must have a valid credentials, and to use any part of the system users must have the privilege level to access those part of the product, and additionally there should be some access restriction mechanism to enforce the protection rules. And additionally, there should be a way to protect your data that the user has entered in your application or web application. So integrity requirement is, as an example, is specified here, and only users who have auditor access privileges shall be able to view the customer transaction history. So you have privilege maintenance applied here, access control applied here, and data protection applied on the customer record or customer transaction history. And additionally, user verification is required at the start of the login process. Another quality attribute important to the user is interoperability. Interoperability indicates how easily the system can exchange data or services with other systems. To assess interoperability, you need to know which other applications the user will employ in conjunction with your product and what data they expect to exchange. So in the simple cases, you have seen the multiple examples on internet where you need to log in and the application provides you to log in using the credentials from Facebook or Google account. And similarly, some applications allow you to integrate your product to share some data or products on social media. So example is done here is the you have a user of chemical tracking systems were accustomed to drawing the chemical structure with several commercial tools. So they presented the following interoperability requirements, which states that the chemical tracking system shall be able to import any valid chemical structures from ChemiDraw version 2.3 or earlier and ChemiStruct version 5 or earlier tools. The next important quality attribute requirement to the users is the reliability. Reliability is closely linked with the availability and the probability of the software executing without failure, or and in the same case as the availability mean time to failure for a specified period of time is known as reliability, and it is often referred as the errors in kilo lines of code. So frequency of failure, recoverability, or predictability also refers to the same case of quality attribute of the reliability. And there are different ways to measure the software reliability, which include the percentage of operations that are completed correctly and the average length of time that the system runs before failing. So it is again closely linked with the availability. So to establish quantitative reliability requirements based on how severe the impact would be if failure occurred and whether the cost of maximizing reliability is justifiable. As an example, no more than 5 experimental runs out of 1000 can be lost because of software failure. So if your software fails less than 5 times whenever you run 1000 times, you can say your reliability requirement has been achieved. The next quality attribute important to the user is robustness of your system, and it is also called fault tolerance. The robustness is the degree to which a system continues to function properly when confronted with the invalid inputs. So your system should be robust enough that if the user misuses it, there should be no loss of the data and no crashing of your system. It also should work properly when the defects in the connected software or hardware components and unexpected operating conditions. So it states that if whenever uh, user feeds your system with the invalid inputs, or there is some software failure or unexpected condition, your system should terminate gracefully and provide valid information to the user that a problem has occurred instead of crashing in front of user. So robust software gracefully recovers from the problem situations and is forgiving of the user mistakes, often referred as graceful degradation. So in simple terms, instead of whole crashing of your system should provide information that some component is missing or some error has occurred. So when eliciting about the robustness requirement, the analyst must ask the user about the error conditions the system might encounter and how system should react to counter those robustness. So here are the examples for the robustness. And the first robustness uh, requirement states that whenever you are saving a file into a program and you accidentally close your program, or the system shuts down the program with some error, the user should be able to revive those files that have been continuously saved. Similarly, another requirement states that all plot description parameters shall have a default value specified, which the graphic engines shall use if parameters input data is missing or invalid. Usability is also one of the key requirements desired by the user, and usability refers to the ease with which the system can be learned and operated by the intended users. So it is also referred as the ease of use, and human engineering usability addresses the myriad factors that constitute what users often described as user friendliness. So in the usability, software designed for effective and unobtrusive usage so that there is no hidden meanings in the user interfaces, and user is able to discern the user interface in a very least amount of time and is able to up and running with your system. Usability measures the effort required to prepare input, operate, and interpret the output of the product. Similarly, human factors are also involved in the usability, and there should be some help or documentation must be provided to the user to use your product, and there should be some measures for to measure the usability, such as required training time, task time for typical tasks, and conformance to the usability standards. So to further understand the concepts of usability in the quality attributes of the product, example is done here that first of all your analyst should have to identify the non-functional requirements of the for example, in this case for the chemical tracking system, analyst asked their user representatives questions such as for them how important it is to able to request chemical quickly and simply, and how long it should take to complete a complete chemical request. So about the discussion of the usability of these requirements, there should be some measurable goals to measure the outcome of the requirements. For example, a trained user shall be able to complete a full request for a chemical selected from a vendor catalog in an average of 4 and maximum of 6 minutes. So you can specify if your user is able to achieve this requirement, you can say your system or your product is usable to the users. So usability also encompasses how easy it is for the new or the infrequent users to learn to use the product. For the new users, you can measure that the chemist who has never used the chemical tracking system before shall be able to place a request for a chemical correctly with no more than 30 minutes of the orientation. So these are some requirements or quality attributes which are most important to the users. Now we turn our discussion to the attributes which are more important to the developers, and the first in the list is the maintainability. So maintainability indicates how easy it is to correct a defect or modify the software. Maintainability depends how easily the software can be understood, changed, or tested. High maintainability is critical for products that will undergo frequent revisions. So whenever there are different versions of your product or you want to incrementally follow the process or software development life cycle, you have to have maintainability in your system to minimize the resource cost. So you can measure the maintainability in terms of the average time required to fix a problem and the percentages of fix that are made correctly. Supportability is the availability of the software to be easily modified, accommodate enhancements and repairs. It includes maintainability, adaptability, configurability. So an example is done here that a maintenance programmer shall be able to modify the existing reports to conform to the revised chemical reporting regulations from the federal government with 20 labor hours or less development effort. The next requirement important to the developers is portability, and it is the effort required to migrate a piece of software from one operating environment to another. Some practitioners include the ability to internationalize and localize a product. Internationalization means if your product is developed by a native uh, developers or for the native users, your system should be portable enough to be used internationally. And if on the other case, if the product is developed in the international users, it should be able to localize itself to meet the needs of specific society. So, which you can say is mostly done in current products. As you can see that most of the good products are made international and they change their perspective to meet the societal needs such as social networking sites and news applications adapt their news with respect to area of the users, and the common examples of the portable applications are Facebook, Twitter, BBC, News, etc. So portability goals include that you have to identify those portions of the product that must be movable to other environments, and it should describe those target environments. So as an example, some compilers define an integer as being 16-bit long and the others define it as 32 bits. So to satisfy the portability requirements, a programmer might symbolically define a data type called word as 16-bit unsigned integer and the word data type instead of compiler's default integer data type. This ensures that all the compilers will treat data items in type of word in the same way, which helps to make the system work predictability in different operating environments. Another important quality attribute important to the developer is the reusability, and it is also very effective in the incremental development and subsequent developments of the products which are similar to the previous product. So it indicates that the relative effort involved to convert a software component for use in the other application. So developing reusable software costs more than the simple software, but it intends to use itself in the multiple applications rather than in just a single application. So reusable software must be modular, that it has modules, and it should be well documented that what each module and the part of the module does for the product, and it should be independent of specific application and operating environment and some generic capability. And most of the reusability components are devised in DLL, dynamic link library files, which can be embedded to multiple applications or web services. Also, some examples include some examples of reusability in which the service can be used by multiple applications. So, as an example, the chemical structure input functions shall be designed to be reusable at the object code level in other applications that are international standard chemical structure representations. So the terminal requirement for the developers is the testability, and it is also known as verifiability, that your developers should be able to test and verify the logic of your product. Testability refers to the ease with which software components or integrated products can be tested to look for defects, and it is somewhat difficult requirement to achieve if your system has complex algorithms and logic, or if it contains subtle functionality of interrelationships between the components. Testability is also important if the product will be modified often, because it will undergo frequent regression testing to determine whether the changes damage any existing functionality. So an example of the testability says that the maximum cyclomatic complexity of modules should not ex exceed 20. A cyclomatic complexity is the measure of number of logical branches in a source code module. So there are other non-functional requirements which also must be met as a quality attribute. However, many of these requirements are catered by the previously defined requirements. For example, as we defined efficiency requirement, which was most important or second most important to users, is also referred as performance requirement. Similar to the efficiency, performance requirement defines how well or how rapidly your system must perform specific functions. But instead of resource usages, the performance is more related to the speed, that how fast it is to find out the results from the databases, for instance, or throughput, that how fast it is to perform transactions, and capacity, that how fast it is, how many transactions can run parallel, and how fast are the timing demands. And if you have very stringent performance requirements, it will seriously affect software design strategies and hardware choices. So you have to define the performance goals that are appropriate for the operating environment. And these, for example, a performance requirement can say that buyers want to complete the sales processing very quickly, and one bottleneck is external payment authorization. And our goal is to have the authorization in less than 1 minute 90% of time. And all users want their application to run instantly, but real performance requirements will be different for the spell check feature of a word processing program and a radar guiding system for a missile. So you have to cater the performance requirements with respect to performance goals and the overall scope of the product. So performance requirements should also address how the system's performance will degrade in an overloaded situation, such as when an emergency telephone system is flooded with the calls. So as an example, performance requirement states that the interpreter shall parse at least 5,000 error-free statements per minute. Similarly, every page shall download in 15 seconds or less over a 50 kbps modem connection, also a performance requirement. And another requirement states that the authorization of ATM withdrawal requests should not take them more than 10 seconds. One another requirement, non-functional requirement, is the external interface requirement, and it is between the system and the outside world. External interface requirements specify hardware, software, or database elements in which the system component must interface. These also include the user interfaces, which can be captured by the usability requirements, hardware interfaces, software interfaces, and communication interfaces. So these can be measured in interoperability and portability requirements. Some requirements are referred as constraints on the system. So these put restrictions on the choices available to the developers for design and construction of the product. So constraints do not affect the external behavior of the system but must be fulfilled to meet a technical, business, or contractual obligation. For example, design and implementation constraint put on the system states that the system shall be developed using the Microsoft .NET platform. This does not affect the output of the system. This only affects the technical aspect of your system. And the other requirement states that the system shall be developed using open source tools and shall run on the Linux operating system. So again, it is a technical requirement and it must conform the contractual obligations of the open source tools. Another example states that the system shall integrate with the existing legacy system, which is the business requirement, and the legacy system is the course catalog database which operates on the college DEC VX mainframe, again which is the technical requirement and it does not affect the output or the working of your product. So constraints can be different, such as design constraint. For example, you can put a restriction, or your development team can put a restriction that it requires the relational database. For example, the persistence of the data will be handled by the relational database. There can be some interface constraints such as protocols for the interaction with the external systems, such as some systems require you to handshake before communicating, and some systems may restrict you to use only HTTP protocols, and some may require to use TCP/IP protocol. There can be some implementation constraints such as described in the previous slide, that you have to incorporate some standards, platforms, or implementation languages such as Microsoft .NET Framework, or in case of databases you can put a restraint that it must use the Oracle 8i database engine. There can be some physical constraints such as hardware devices in their shape, sizes, and weights as well. So by this time you must have a clear picture of the functional and the non-functional requirement. And I will reiterate here that the non-functional requirements cannot be achieved directly without the achievement of functional requirement. and the designers and the programmers will have to determine the best way to satisfy each quality attribute and performance requirements. Again, quality attributes are non-functional requirements which cannot be directly achieved, so they lead to derived functional requirements or design guidelines or other types of technical information that will produce the desired quality characteristics. So in simple terms, you have to achieve the functional requirements to a certain level to enforce the quality attributes or non-functional requirements of your product. So a single non-functional requirement such as a security requirement may generate a number of related functional requirements that define the system services that are required. So it may also generate the requirements that restrict the existing requirements. So you have to be very clear here that you have to achieve the functional requirements to a certain amount of level to enforce the non-functional requirement on the user. And in some cases, the non-functional requirement may enhance the non-functional requirement, and in some cases, it may restrict the non-functional, functional requirements to achieve the non-functional requirements. So as an example of implementing non-functional requirement, a medical device with the stringent availability requirements might include a backup battery power supply, which is referred to the architecture, and a functional requirement to visibly or audibly indicate that the product is operating on the battery power, which is again a functional requirement. And in the achievement of the functional requirement, you can say you are indirectly achieving a non-functional requirement. This translation from the user-centric or developer-centric quality requirement into the corresponding technical information is the part of the requirement and high-level design process. And the table on the next slide indicates that the likely categories of technical information that different types of quality attributes generate. So you can look or refer to this table as implementing non-functional requirements in terms of quality attribute types and their likely technical information category. And if you have to achieve the integrity, interoperability, robustness, usability, and safety, and these requirements will be most likely to called functional requirements. So if you have to achieve the availability, efficiency, flexibility, performance, and reliability, again you have to achieve the functional requirements, but these requirements also referred as system architecture. And again, if you want your system to work with different applications, you have to again work on the design constraint or system architectures. Again, some requirements are related to design guidelines such as flexibility, maintainability, usability, testability, and reusability again. And portability is also referred as implementation constraint. So these are some technical information categories or terms used to describe the quality attribute types. However, all of these requirements must be put in your system to achieve non-functional requirements. And requirements are also imprecise and inaccurate most of the time, and the problems arise when the requirements are not precisely stated. As we have discussed in the lecture number 1, that most of the product failures occur due to the incorrect or imprecise requirements, and sometimes ambiguous requirements may be interpreted in different ways by the developers and the users. For example, consider the term search in the requirement. 1. User intention is to search for a patient name across all appointments in all clinics. And in case you are a developer, you can interpret the search from the requirement that search for a patient name in individual clinic. So user chooses clinic, then search. So it can create an ambiguity and difference between the actual requirement and imprecision or translation of those requirements to the system. So you have to work with the user to craft specific, most importantly, measurable and verifiable requirements for each attribute. So if the quality attributes are not verifiable, you cannot tell whether you have achieved those quality attributes or not. So as stated earlier, to clear the requirement specifications, you have to work with the user, and those requirements should be specific, measurable, and verifiable. So whenever being appropriate, you have to specify measures to identify the scales or units for each attributes, and you have to specify what is your target measure. For example, as specified in efficiency, that you want to achieve the task in less than 5 seconds. That is your target measure. You also have to specify minimum and maximum values. For example, in some cases you have seen that 95% of the time your users are able to complete a transaction in 1 minute, and you can say that 99% or 1% of the users should not take more than 2 minutes to do a specific task. And sometimes these notations are called language notations, and which helps with this specification. So if you cannot quantify all the important quality attributes, you have to define their priority. So you can consider asking the users what should constitute an unacceptable performance: usability, integrity, or reliability, such as allowing unauthorized access to the users to delete files. So in simple terms, you have to identify, if you cannot quantify, you have to identify what is an unacceptable non-functional requirement. So if you are able to define unacceptable characteristics, a kind of inverse requirement, that means what is not desired by your product, you can devise a test that attempt to force the system to demonstrate those characteristics. So this approach is particularly valuable for safety critical applications in which a system that violates reliability, performance tolerances poses a risk to life or a limb. Again, the main focus is the goals and requirements. Non-functional requirements may be very difficult to state precisely, and imprecise requirements may be very difficult to verify. So you have to first try to be very precise, measurable, and verifiable requirements. However, it is a difficult process, and some requirements may not be stated precisely. So you have to specify goals. Goals are helpful to developers as they convey the intentions of the system users. Goal is a general intention of the user, such as ease of the use, and it is verifiable non-functional requirement. A statement using some measure can be objectively tested. So you can say that the system has the ease of the use if 95 of the percent of the users can use the system with no help or minimum help of the documentation required can use your system. So here is an example done for you to convert a goal into a non-functional requirement. So again, our goal is unverifiable, but it states the intentions of the user, that what your users wants from your system. And the goal states that the system should be easy to use by experienced controllers and should be organized in such a way that the user errors are minimized. So you have to extract the non-functional requirements, that the experienced controllers should be able to use all the system functions after total of 2 hours training. So again, you have put an unverifiable goal to a verifiable non-functional requirement by specifying a measure to achieve the non-functional requirement. So a measure here is the 2 hours of training time. So after this training, the average number of errors made by the experienced users shall not exceed 2 per day. So again, the ease of use is measured as 2 hours training time, and the number of errors are measured as 2 per day. So there are different metrics for specifying non-functional requirements. For example, if you want to specify a goal, or if you want to convert a goal from which incorporates speed, you can use the measures of transactions per second, event response time, or screen refresh time. Similarly, the size is measured in bytes or chips. Users use is measured in training time and help frames. Reliability or availability is measured as mean time to failure, unavailability, rate of failure, or availability itself. Robustness is referred or measured in time to restart, percentage of events causing failure, or probability of data corruption on failure. Portability is the percentage of target dependent statements and number of target systems. So whenever you are specifying the quality attributes, you have to make a trade-off to achieve one quality attributes, and you have to compromise on the other quality attributes. So in an ideal universe, every system would exhibit the maximum possible values for all of its attributes, but in general terms, it is not achievable, because the perfect condition is unattainable in this world. You have to learn which attributes are most important to your project success. So then you can define the user and developer goals in terms of those essential attributes which you have the most priority in your product, and then your designers can make appropriate choices. So different parts of the products need different combinations of quality attributes. So efficiency might be critical for certain components, while usability is paramount for the others, and in some cases you can look to achieve integrity or security, and in some cases you look for the portability. So you have to differentiate quality characteristics that apply to the entire product from those that are specific to certain components or certain user classes or a particular user situation. So you have to document any globally quality goals in the software requirement specification document and associate specific goals with the individual features, use cases, or functional requirements. Some attributes are critical to embedded systems such as efficiency and reliability, whereas others might be especially pertinent to internet and mainframe applications such as availability, integrity, and maintainability, or some to desktop systems such as interoperability or usability. Embedded systems often have additional significant quality attributes including safety, installability, and serviceability. Scalability is another attribute that is important to Internet applications. So users and developers must decide which attributes are more important with respect to priority and then must respect these priorities consistently when they make decisions on your product functional or non-functional requirements. So you have to figure on next slide you have figure on the next slide of some technical interrelationship among quality attributes, although you might encounter exceptions to those because these are just some guidelines. And a plus sign cell indicates that the increasing the attribute in the corresponding row has a positive effect, and the negative sign is that if you increase the one quality attribute, the other decreases the effectiveness of the other quality attributes. So as you can say, if you increase the availability, you automatically increase the reliability and robustness of your system. And if you increase the efficiency, it can have the opposite effect on the most of the requirements. Similarly, if you increase portability, there are some requirements consideration uh, which are inverse to portability or efficiency and maintainability and usability. So you can go through this table, and this is again a generic table to refer as a guideline, and it may not be accurate for all of your projects. So the trade-off matrix is not symmetrical because the effect that increasing attribute A has on attribute B is not necessarily the same as the effect of that increasing B will have on A. So for example, designing a system increasing efficiency does not necessarily have any effect on the integrity. However, increasing integrity will likely to hurt the efficiency because the system must go through layers of the user authentications, encryptions, virus scanning, and data checkpointing. So to reach the optimum balance of the product characteristic, you must identify, specify, and prioritize the pertinent quality requirements attributes during the requirement elicitation phase. As you define the important quality attributes to your product, use the trade-off matrix to avoid making commitments to conflicting goals. Excellent software products reflect on optimum balance of competing quality characteristics. For example, highly robust code will less efficient because data validations and else checking that it performs, it will greatly reduce the speed of your code or product. Over constraining systems is again a problem, and it expects or definition of conflicting requirements make it impossible for developers to fully satisfy the requirements. So you have to put the constraints on the requirements with respect to the trade-off matrix. You have to ask the user representative to rank each attribute on the scale of 1 to 5, giving the importance 1 as lowest and 5 as highest. Different user classes sometimes have different quality preferences, so the favored user classes gets the nod whenever conflict arises. So if you want to learn more about the topic, you can read the recommended book or you can ask any questions. Thank you very much.